Hello, everyone. Welcome back to another episode of Daily Coding. So today is day 8. Um, it is January 23rd, 2025 at 2:45 p.m. Feeling all right today. Had a bit of a headache today, so hopefully that doesn't get in the way. So yesterday I attempted the Advent of Code problem 16 unsuccessfully. So I did some research into this type of problem, and I think I need more familiarity with some graph algorithms, like I think it was uniform cost search or something like that. So instead, what I'm going to do is complete this roadmap, and hopefully soon I'll get to the graph section, advanced graphs. Yeah, like maybe this is just the exact problem or something. So anyway, so the recommended order here. So I've done 2 pointers, all the mediums, sliding window. So today we're going to be doing linked lists. I think I did. Okay, I still have a binary search I could do. Yeah. So disclaimer: I want to preface this. I'm pretty inexperienced with linked lists, so this might be painful to watch for anybody who knows what they're doing. So So yeah, without further ado, let's jump into it here. So today we're doing remove node from end of linked list. Okay, so we are given the beginning of a linked list head and an integer n. Remove the nth node from the end of the list and return the beginning of the list. Okay, so here we want to remove the second from the end. Okay, so the size is between 1 and 30. 1 and 30. And n can be 1 or it can be the size. Okay, recommended is O of n. So I don't know if I'm crazy. I could be crazy. But what I'm thinking is you just take the length. So get length of linked list. And then you iterate through the list with a counter I. And then when I equals length minus n, then you just remove link, or I guess remove node at I, right? Am I crazy? And there is an exception if we want to remove first or last element. So to get the length of a list, I'm going to say length equals 0. And I'm going to say current equals head. And while current, length plus equals 1, current equals current.next. So let's print the length here. So this should give us the length of the list. So here it gives us 4, and here it gives us 1. Okay, so that seems to be working. Okay, so now we have length. Okay, so now we're going to find the nth from the last list. Oh, and it only wants to return the beginning of the list. Remove the nth node. So this is second to last. Return the beginning of the list. And then 1, 2, you remove 1. Okay. I'll return the head of the new list. Okay. Yeah, sure. Okay, so I equals 0. And then we're going to say while I, so for instance, if we have 1, 2, 3, 4, our length equals 4. So I here will be 0. So we want it to stop when I is what? When I is the one that we want to remove. Let's say that. So if n equals 2, we want to stop when I equals L minus n. So while I is less than length minus n, I plus equals 1, and current equals current.next. Okay, so now let's print I, and this should give us the index of what we want to remove. C has no attribute next. C equals head. Okay, so 2, 0, 1, 2. Remove the first one. Okay, exactly. Okay, so this gives us the index. So if we print c dot val, so if we print I c dot val, this should give us the value itself that we want to remove. So I is 2 and value is 3. And here value is 0. Okay, perfect. So now we've identified that. So I think what we're also going to want to say is previous equals none. So we'll say previous equals current because we want a previous. So for instance, to remove a node from a linked list, if we have, this would be current and this would be previous. So all we want to do is just set previous next to current next, and that will remove this chain. Okay, so now remove at node I. So I guess, well, we have previous and current to what we want. So we'll just say previous dot next equals current dot next. If previous does not equal none, so if previous, then otherwise, so if it's the first element, then we would say head, or I suppose we could return. Can I set the head? Maybe just like return C. So that would be, so like for instance, if we want to remove 1, so head goes here. So we just return this list instead. Okay. Let's see what happened there. Your output is empty list. Do I have to return something? Yeah. Let me try that. Okay, that worked. And this returned 5, which is the head. Okay. So another case that we want to consider is if we are removing the last element. So if we are removing 4, so this points to none, so we'll have previous here and current here. So we want to set previous to none. But this is not true, so previous, okay. So in this case, we have 4 points to none. Okay, let's just say, so if previous equals none, so there's two cases. If c dot next also equals none, then return none. Otherwise, so this is one element list. And we don't have to check if it's like within it because it says n will be within the size. So if previous is none, then this means remove first element of length greater than or equal to 2. So in that case, we would just return current. And if P is populated, then we return head. Runtime error, : Oh, well, I didn't do P dot next equals C dot next. Okay, let's run that. Wrong answer. 1, 2. So if we have 1, 2, and we want to remove the first element, so here P is none. C dot next does not equal none, so we return C. Oh, we want to return C dot next, of course. Okay. All right, awesome. Okay, that seemed really easy. I don't know if that's how I was supposed to do it. Let me look at the hints. I don't use extra space. Maybe you should first solve with a 2-pass approach. First finding the length. How can you remove the node? A greedy calculation. Okay, we can solve in 1 pass. I'm just going to close hint 4 because I think that one had the answer. Oh. Well, I do have an idea, actually. For 1 pass. So this works, but for a 1-pass solution... Sorry, someone's blowing up my phone. I have to silence it. Okay, so for a 1-pass solution, what you could actually do is have a thing, like not a thing, like a look ahead that points n spaces ahead. So for instance, let's say you have 1, 2, 3, 4, 5, and you want to remove the n equals 2, so second from the last. So that means you set current here. Or I guess we'll say previous here, and then current is 2 spaces ahead. So then you move both of these here, and then here, and then here, like that. And then when current equals none, you know you have to remove P. So actually what we should do instead is keep this as current and previous, and then have a third pointer called like A for ahead or something. So it will go ahead. And yeah. So once A equals none, then you know. Okay, so with some tricky cases, if we think of, for instance, 1, 2, like that, and n equals 2. So we set current here, and we set current here, and look ahead here, and previous is none. So in this case, n, you can never have something where A goes ahead of none, because n must be less than or equal to size. So similarly, if you just had a 1-element list like that, it would be current and ahead, because this is n spaces in front of it, which is 1 space, and this is n spaces in front of it, which is 2 spaces. So in this case, I think it's just the same thing. Once you have current here, this whole strategy just tells you where current is. Once you have current, I'm pretty sure it's the same thing. So if we comment out all of this, how we can do it in one pass is say, well, in order to get A that many spaces ahead anyway, you would have to say, like, for I in range n. So, okay, so for instance, if we say current equals head, so let's set our pointers, previous equals none, and then we say ahead equals, you actually have to define it in terms of n. So for basically whatever in range n, so we're going to repeat this code n times. We want to say A equals C dot next. Or no, we would say A equals A dot next. And A equals C. I guess we could say, yeah, that's fine. Let's do that. So it'll move ahead n spaces. So the problem with this is now this is O of n anyway. So I don't know if this is even considered one pass through anyway. I'll just solve it like this, and then we'll call it for the episode, because I think this is good. I think it's still good. It was O of n. Okay, so now we want to say while A does not equal none, move everything up by 1. So previous equals current. Current equals current dot next, and A equals A dot next. So we're moving everything up by 1, and then once A equals none, which it might like instantly, then we know that current is in the right spot. Okay, so let's try running that and submitting that. Sweet. Okay, so we got a little bit of a different way. Instead of calculating the... So this solution is actually a little bit better, because instead of calculating... So this part of calculating the length takes time always, no matter what, the length of the list. Where this takes time of n. And n could be less than the length of the list, even though it's... Actually, wait. It's still one pass through anyway, actually. This whole thing is one pass. Because if you think about it, A never goes to the left. So A goes here, here, here until it's n. And then it stays there and keeps going. So it's still the length no matter what with only one pass. So I think that is the correct solution. And then this part is just some tricky if statements for the edge cases. I don't know if you need that. I think you do. Well, maybe you don't need this because it says if this equals none, return none. And this says return c.next. So I think we always just actually return c.next like that. Not like that. Because yeah, if it equals none, then return none. So you're returning c.next here and returning c.next here too. So that should also work logically. Okay. So could I say if not p, is that the same thing? Okay, sweet. Yeah, this is pretty good. I usually never do linked list solutions. So this is making a lot of progress for me. Yeah, so a pretty short episode today. Yeah, this will be good because we can kind of make some progress on this roadmap. And yeah, I'm really looking forward to getting the trees because I was struggling with these. And then, you know, I've been hearing a lot about heaps and priority queues, so I'm excited to do more of those, backtracking and graphs. So there's a lot of exciting stuff coming forward. So that's today's episode. We're going to have 4 more days, it looks like, of linked list here. And I'll save the hards for maybe when I'm done with the whole map, I'll come back. Yeah, perfect. All right, see you guys tomorrow.